We will now create a very interesting vortex shape based on the tools that we already have. We just need to add a bit of functionality, but it shouldn't be that complex. So first of all, let's try to change the shape a little bit. So I will go back to the box and probably replace it with another geometry. I will create a tube. Make sure it has caps on the top and on the bottom. And let's make it relatively high. Let's say about 4 times the current size. Probably even more, maybe 6 meters high. And let's make sure to create a polygon rather than a primitive to be able to flex it and to deform it. So let's add a little bit of rows and columns. Let's increase the rows to 100 and the columns to 40. Now let's give the cylinder a tapered look. This can be achieved relatively easily by just adding a few lines of code. So let's drop down a point wrangler node. Let's call it taper. And let's write the following code. V at p.x times equal. So we will multiply the current x position of each point by rel bbox open parentheses at p close parentheses dot y semicolon and evaluate. So as you can see, all the points in the bottom are moved toward the center or towards value 0, and the top points are being multiplied by values closer to 1. This is why they stay in their same position. So let's do the same for the C axis. I will copy this line of code, paste it, and just change the axis to C. We'll replace X by C. And now we have a perfectly shaped cone. The only thing I want to add is a small curvature, and I will do that with a small trick. I will elevate this value to the power of a number. For example, type pow, open parentheses, and inside the parentheses, I will leave the current value followed by a comma, followed by an exponential, for example, 2 and close parentheses. Now let's evaluate and see what happens. So notice now how on the front view we can see a very nice curvature going from bottom to top, and we could exaggerate this curvature by elevating this exponent, for example by 3 or even by 4. So let's apply the same change to the C position. Let's type pow or power, open parentheses. Let's leave the rel bbox as is, followed by a comma, and let's elevate to the power of 3. Okay, same for the X position. I will elevate to the power of 3. And I think this is a very nice starting point to create our volume vortex. So let's connect the geometry to this node to set the density. Actually, we need to connect it to the VDV. Now we have our density. For now, let's just turn off this node. We don't need an offset for now. Let's change that to 0. But we do want a few voxels on the borders, so we will leave the VDB activate. Of course, we want the noise. Let's probably lower the amplitude of the noise. Let's try with 1 or even 0.5. And let's add the second noise too. Let's decrease the amplitude to more or less 0.35. Let's now create the vortex shape by twisting the volume around its center. So first of all, let's add another volume wrangler. And we will call this one twist. Again, change its color. And the first thing we need to do is create the rotation. Rotations can be done in several ways, but in this case, we will use a quaternion, which is a vector 4 type of value. We need two things to create a quaternion. First of all, a direction vector, and second, an angle. So let's start creating an angle first, and that can be a float value. So let's do a variable called angle, just like that. And let's hard code a value of 6.18 for now. And add a semicolon and evaluate. Now we're going to create a vector variable called new pos or new position that will be the result of rotating this quaternion. For that, I'm going to use a function called qRotate. So inside this function, we will need our quaternion, and we will need to rotate the position of each voxel. So in here, we will create a quaternion. For that, we will type quaternion, open parentheses. We will first give it the angle, followed by a comma, and then we will set the vector direction. In this case, we will make it pointing towards y positive. So type 0, 1, 0, and close the curly brackets. Okay. Once we have defined this rotation angle, we can assign this rotation to the actual voxels. So let's use our volume sample to do that. So let's type f at density equals volume sample, open parentheses, 0, 0, new pos, which is our vector that we just created. So let's see what happens. Notice how the voxels were rotated by this value. Let's try increasing it. And now you notice it rotated much more. So here's the thing. The quaternion will expect a value in radians, which right now we are feeding here. But usually we're thinking in terms of degrees. So let's convert whatever value we put here to radians. Say, for example, I type 180 degrees. I want to convert that value to radians. And we have done that before. Let's type radians, open parentheses, and let's type, for example, 180, close parentheses. So now we're rotating the volume by 180 degrees, which is probably not that useful. What we want to do is the upper voxels, we want them to twist or to rotate much more than the lower voxels. So we can do that by multiplying this value by our rel bbox value. So let's multiply this value by rel bbox at p, And in this case, we only need the vertical axis or the vertical value. So let's type .y and evaluate. So now apparently it's working fine. Let's create a channel to be able to increment the angle interactively. So let's replace this value by a channel called angle. Let's create our interface. And now notice how the top voxels are twisting much more than the lower voxels. So far, I'm liking the functionality of our tool, but I would like to make just a small improvement. If you take a look from the top view, you will notice that no matter how much we increase this angle, the voxels are only rotating. Even if they're rotating more at the top, we are not achieving a very twisted shape. And we can do that by making the exterior voxels rotate much more than the interior voxels. And we can achieve that by computing the length of each voxel from the center axis, or in this case, the y-axis, and multiply that value by the angle. So let's try this. I will go back to my perspective. And here, where we're creating the angle, I will put everything between parentheses. And now I will multiply this value by the length. So I will use the length function of the current position of each voxel multiplied by a vector. And this vector I will set to 1, 0, 1. So I will close parentheses again, and evaluate. So notice now how the shape from above seems to be much more twisted and more like in a spiral. So again, to achieve this, I'm multiplying the angle of rotation by the length of each voxel's position relative to the center axis. So the further away each voxel is from the center, the more it will be rotated.